Hello, today we're going to talk about the chemical basis for life, Anchor 2. On the first slide, we need to define some important vocabulary words. Matter is anything that takes up space and has mass. And if we go down and we talk about all matter is made up of molecules or compounds, and we even go further to say that all compounds and molecules are made up of atoms, we can therefore say that atoms are the basic building block of matter. So what is an atom made up of? They are made up of protons, electrons, and neutrons. If you can think of a pen, P-E-N, where P stands for protons, and they are positively charged. E stands for electrons, and they are negatively charged. And N stands for neutrons, which they are neutral and they have no charge. If we look at this slide here, if they don't have in the first valence shell 2 electrons, then it would be unstable. If it has 2, then the first valence shell is stable. All others must have 8 electrons in order to be stable. If it has less than 8 in the outer electron shell, then it would be unstable. If it's unstable, then it would need to form a bond where it would become stable. 2 types of bonds that we discussed this year are covalent bonds. C is for sharing. Covalent bonds are sharing. Ionic bonds are stealing. So C is for caring is sharing, or ionic bonds, stealing. If we look at the top picture represents a covalent bond. The bottom picture here represents an ionic bond. Water is the most important compound found in living things. When we talk about water, you have to recognize that water is a polar covalent bond. Polar meaning it has opposite poles, that they are unequally shared. They have a positive end and a negative end. And water is held together weakly by a hydrogen bond. Water's 4 unique properties. Water is sticky, and it has S. Remember I said that to remember water's 4 unique properties, remember S. So the first one is sticky. Water is sticky. And when we talk about sticky, we need to address the 2 terms cohesion and adhesion. Cohesion, water sticks to itself. Adhesion, adhesive, water sticks to other substances. Like Band-Aid sticks to your skin. You have 2 different substances. The reason that it is so important to know that water is sticky is because it moves water up the plant or up the tree so that it can live. The second unique property of water is that it changes temperature slowly. The second S, slowly. Water must gain or lose large amounts of energy for the temperature to change. This is important so that we don't overheat our bodies, which are made up of 75% water, or to heat up the ocean or bodies of water that heat them up very quickly so that the organisms would die. The third unique property of water is ice floats. This is a stretch, but it ends in an S. Alright, ice is less dense than water, which insulates the water underneath. Why do we care? Because that sustains life. If it freezes, the animals below will not be dead. 4. Water can mix with many substances. That's our 4th S. When we think of water can mixes with many substances, we need to think of the words solute, which that is what is being dissolved, like salt, like sugar, like Kool-Aid. We have to think of solvent, the thing doing the dissolving, like water, dissolving salt, or milk, dissolving the hot chocolate mix. And then we have to think of solution, which is both the solute and the solvent, hence chocolate milk or lemonade. The next slide shows you pictures. And if we look at the macromolecules, remember that I said clap. C-L-A-P. And I said refer to it as big clap, where macro means big, and we can remember the order C for carbohydrates, L for lipids, A, this is a stretch, but that's nucleic acids, and P stands for proteins. So when we talk about our organic compounds, think of macromolecules, big clap. When we look at the macromolecule carbohydrate, we have to know its monomer, which means 1. Mono is 1, and the monomer of carbohydrate is a monosaccharide. There is a disaccharide, which di means 2, and there is polysaccharide, which means many, and that's a polymer, is polysaccharide. How do we identify the structure? You can learn it as count up the C's, and there should be 6 C's. The H's, there should be 12 H's. And the O's, there should be 6. So a way to identify the structure is to have 6 C's, 12 H's, 6 O's, or the structure as the hexagon, which I'm having trouble drawing here, but there are 6 sides to it. Hence you get C6 and O6. What is the function of a carbohydrate? Energy. You eat Doritos, you get energy. You eat a salad, you get energy. The second one is lipids. Lipids, the monomer is glycerol or a fatty acid tail. That's a way, and you can think of fats, F-A-T. Lipids are fats. They are made up of a fatty, F, acid, A, tail. That's a way to remember the monosaccharide, or the monomer. Examples of the polymers are triglycerides and phospholipids, which triglycerides, their function over here is lots of energy storage. If we're talking about phospholipids, well, that is what is made up of, it makes up the cell membrane. And you can see the pictures here of the phospholipid. And steroids are a unique example. They are 4 carbon rings. If we move on then to proteins, the monomer, its simplest unit, is amino acids. You may see the polymer as polypeptides, which we know it as protein, also known as. How we determine the structure is that it contains, if you look over here in the chemical diagram, it has an N for nitrogen. And the function of a protein is it conducts all cell functions, such as immunity, such as fixing and repairing cells or muscles. Immunity, I-M-M-U-N-I-T-Y. But if you remember, if you can't remember anything else, remember that. Or it conducts all cell functions. Finally, we move on to nucleic acids. Their monomers are nucleotides. The polymers are DNA. DNA is double-stranded, the double helix, and RNA is single-strand. Their structure, you can see over here, that would be, the first one I circled is RNA, it's a single strand, and DNA is a double strand. Its function is to control the cell's function through the production of proteins. If we move on to the next slide, how are monomers put together? Okay, mono means one. How do we put them together? In order to build a bond, we need to look here. We have 1, 2, and 3 are bonded. Notice that there is an H over here, and notice that there is an OH, and notice that they are not bonded. There's no line connecting the H and the HO. And we have over here number 4 with an H over here. So what we have done as we take out H2O, and it shows it as here as it's coming off, we are removing oxygen. When we remove the oxygen, notice that the number 4 scoots over to bond with number 3. So now we have 1, 2, 3, and 4 that are bonded, and it shows them as all connected with lines. Where up here, it didn't. So when we build a bond, we take out water. So dehydration synthesis are two monomers covalently bonded together through the loss of water. If we look over on to the next, to the right, we see hydrolysis. We see that 1, 2, 3, and 4 are bonded. We see that water is added to the arrow. There's an arrow pointing in. And we see now that the final result is 1, 2, 3, separated by water. They're not bonded. And you have 4 over here. So in order to break a bond, you add water. And if you can think of this as when you eat dinner, you are breaking bonds of the food by drinking water with your meal. Hence the term hydrolysis. Hydro means water. Adding water, break bonds. The final slide is talking about enzymes. Enzymes are important because they catalyze. And catalyze is a very important word. Enzymes have catalyst or catalyze, and they are helpers. And what it does is it speeds up the reaction. So enzymes that catalyze speed up the reaction. And the reason why it speeds up the reaction is because it lowers the activation energy. By lowering the activation energy, which is in red here, it happens much more quickly. So enzymes are needed to speed up processes. Over here, we see the enzyme. Right here, sorry, the bottom part here. My pen got away from me. This is the enzyme. And above it, I'm having technical difficulties here, so I'm just not going to do that. The enzyme is the bottom portion. The active site is where the enzyme comes together with the substrate. And finally, you have these right here are the substrates, and that forms the product. So the enzyme has a specific shape. If we change the pH or we change the temperature, the enzyme will change shape. If the enzyme changes shape, it will not function. Enzymes are specific. Special lock, special key. They go together. And that concludes Anchor 2.